Okay, I know that I had posted a recording about the angle measures on the unit circle, but I also wanted to include one about where do these ordered pairs come from and how does that play a part and what does that have to do with anything. So let me give you this little nugget of information, and hopefully these little short helpful recordings are helpful to you. And if you're watching them, I'm assuming they are. So let's talk about, we already reviewed in that last recording the triangles and right triangles and how those play into part. And then we also talked about those angle measures and where they come from on the unit circle. So basically the unit circle comes from two main things, is all those angle measures, and I'm going to go over that real quickly just so we have a base to start with. And then the other thing is our special right triangles. So you have to know your special right triangles. You've got, ooh, that's a terrible triangle, but let's say that's a right triangle. You've got your 30, 60, 90 right triangle, and that's on the unit circle. And then you have your 45, 45, 90 triangle. Now you've done these relationships before in other classes, but you've never done anything with it. Well, here it is. You're ready to do something with it. All right, so we're always going to say our hypotenuse is 1 because it's always on a unit circle, and the degree of the, or the measure of the radius is always 1. So our hypotenuse is always 1. If we have our 30-degree angle here and our 60-degree angle here, here's how I remember it. I know that one of them is the square root of 3 over 2, and one of them is 1/2. The smaller side is always opposite the smaller angle. Since 30 is the smaller angle, I know this one's going to be 1/2. Since 60 is the larger angle, I know this one's going to be square root of 3 over 2. And I don't remember what square root of 3 over 2 is in a decimal, but it's bigger than 1/2. I don't remember exactly what it is, but you can grab your handy dandy and check it and see if I'm right. I know I am. So anyway, so that's how you're going to use that triangle when we're fixing to do on the unit circle. And the other one is the 45, 45, 90. Let's see if I can make my right triangle look a little nicer. Well, it's not too great, but we're going to mark that right, so that makes it so. Again, our hypotenuse is always 1, and this is an isosceles triangle because they're both 45-degree angles, 45, 45. And so what that tells me, if I used my Pythagorean theorem to figure it out, which I don't have to because I know what it is square root of 2 over 2 and square root of 2 over 2. And technically when you use your Pythagorean theorem, you get 1 over the square root of 2, but you can't leave the square root in the denominator. And that's what happens over here as well. So you have to make sure to rationalize that denominator. But if you'll just remember it's square root of 2 over 2, you don't have to do it every time. All right, so we're going to take that nugget of information and we're going to use it creating the ordered pairs that are found in our unit circle. So let's review this just so we're all clear and on the same page, and then we'll talk about how that goes together. All right, so on our 45, 45, 90 special triangles, we know that this is pi, or 180 degrees. We know this is pi over 2, or 90 degrees. And if we split this in half, if we split 90 degrees in half, this is 45 and this is 45, or pi over 4, 5, 45. Okay, and then if we split that in half. Now, I have taken my 1 pi and divided into 45-degree angles. How many are there? There are 1, 2, 3, 4. So this is pi over 4. This is 2 pi over 4. This is 3 pi over 4. And this is 4 pi over 4. This one will be 5 pi over 4. 5, if I can draw a 5. 5 pi over 4. This one's 6 pi over 4, but we want to reduce it. So 6 pi over 4 reduced is 3 pi over 4. And I went over this real thoroughly in the last recording. So if you're not sure about that, you might want to go back and watch that. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Oops, but reduced. I forgot to reduce. 6 pi over 4 is 3 pi over 2. That's a 2. 3 pi over 2. So 6 pi over 4 and 7 pi over 4. So those are, and 8 pi over 4, which is just 2 pi. So those are our labels for our 45, 45, 90. Now, how does this relate to those ordered pairs? I'm going to take that nugget of information. Actually, I think I'll just do it right here on this one screen. I thought I was going to do it on two, but I've changed my mind. Bigger. All right, so what I'm going to do is I'm going to pick a different color here so that it kind of stands out a little bit. You see, this is just a little triangle, always dropping to the perpendicular. This is just a little triangle, always dropping to the perpendicular. This is a little triangle. You see how great those are? They're just triangles. Each of those ordered pairs at the end, this is just a dot. It's just an ordered pair. I'm going to go over some and I'm going to go up some. And how I figure how much I'm going to go over and up is because I know this is a unit circle. So my radius is 1 because it's a unit circle, 1 unit. And if this is 1 and this is 45 degrees, looky, I know what my legs are. They're the square root of 2 over 2 on a 45-degree angle. I don't have to do any calculating to figure that out. I know this ordered pair at pi over 4 is the square root over 2, comma, square root over 2, over 2, square root over 2, like that. That's what this ordered pair is because I know my special right triangle. This leg has a length of square root over 2 over 2. This length has a square root of 2 over 2 because I'm at a 45-degree special right triangle. Do you see my special right triangle? Hopefully. I see it's hard when I'm doing recordings by myself. I don't know if I'm making sense. I know I am, but all right, take a moment, think about that. So let's look at this special right triangle. It's a 45, 45, 90 as well. And we always drop to the x-axis. You see I don't have any right triangles going on at the y-axis. It's always to the x-axis. Okay, so that being the case, I know that this leg is square root of 2 over 2. This leg is square root of 2 over 2. But if this is 0, 0, the ordered pair, I'm going to go to the left and up. All the ordered pairs in this quadrant should have a negative x and a positive y because that's how they get to the second quadrant. So this ordered pair would be negative square root of 2 over 2, positive square root of 2 over 2. Dun, da, da. I didn't have to memorize that. I just had to know my special right triangles, which you should already know that. And I just had to understand reference angles on the unit circle. And always the radius is always 1. All right, same thing here. The ordered pair is going to be square root of 2, square root of 2, but let's talk about the signs. It's going to be a negative and a negative. So the ordered pair right here is negative square root of 2 over 2, negative square root of 2 over 2. And the one over here would be positive negative. So that's where you're going to get those ordered pairs for the 45-degree angles or the pi over 4s on your unit circle. All right, let's kind of, hold on, let me show you the unit circle. Stop sharing that. Share this document, which I'm going to have to update because there's a mistake on it, but I know what it is, so I will make sure to fix it. Oh, that's too big. Stop sharing that one. Let's try a different one. That's like, I can't even see all that. Try this one. Oh, there we go. Okay. Oh, and I had already done a whole bunch of work on it. This one's negative. Okay, so see our 45-degree angle right here. I wonder if I can take all this off. Can I delete all that? Because this was from that last recording that I did. Let's see if I can take it all off. Oh, yeah. There we go. Let me get this off. There we go. All right, so now we're fresh and clean, except that I want to include this back. This is a negative one. I don't know where that must have got chopped off in my snipping tool or something, but that's a negative one. Okay, so now look, our 45-degree angles on our unit circle are here, right? And there's our ordered pair. Are here, and there's our ordered pair. Are here, 5 pi over 4. And here, 7 pi over 4. Those are where those ordered pairs come from the special right triangles. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, oh, I skipped one, sorry. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. That's where those markings come from, and the ordered pairs just come from the special right triangle that you know is formed right there by dropping the perpendicular to the x-axis. So hopefully you can see that. So don't look at this and go, oh my gosh, I have to memorize that. You don't. You just have to understand where it comes from, because then you can just do it and you don't have to memorize it. All right, so let's get rid of that. So let's talk about how the 30, 60, 90 incorporates into this, because it's very similar, but the ordered pairs are a little different because the special right triangle measurements are different, and that's why it is different. Okay, so let's do, oh, can I fit this on here? Maybe I can. I'll try. Think about it. How can I rearrange this a little bit? I kind of want it to be on here. Let me just move this and see if I can scooch that up there and see if I can I make that smaller? Can I do that? Oh, I can, looky there. I'm just making it a little bit smaller. Very good. Okay, and then I dropped something. I dropped my square root there. I can fix that. Okay. Pencil. Square root when I moved it. And this is 3 pi over 3 pi over 2. Okay, so let's go and do our 30, 60, 90 in the same way, and then we'll see what that looks like on the unit circle. We're really almost done, I promise. Oh, that was terrible. Let's try that over. All right. How hard is it to draw a straight line? Pretty hard. There we go. Okay. Now, 30, 60, 90. Our radius is always 1. So think about it. If we're going to have a 30-degree angle, all 30-degree angles, because 30 plus 30 plus 30 is 90. So our pi over 2 right here kind of dictates how we're going to divide it up. On the 45, 40, 90, right, we wanted 45 and 45 is 90. And here for the 30, 60, 90, we're going to divide this up into sections of 30-degree angles. So this is 30 degrees, 60 degrees, 90 degrees. And then we've got our 30, see, 30, 30, 30, 30. So what we're doing is taking our pi degrees and dividing it into 1, 2, 3, 4, 5, 6 sections. If you can count, you can do this. So this is 1 pi over 6 because I divided it by 6 so that I could get 30-degree angles. That's why I did that. If this is 1 pi over 6, this is 2 pi over 6. I can count. And then, of course, you would want to reduce that. So technically, we're going to call this 1 pi over 3 because we want to reduce. And this would be 3 pi over 6. This would be 4. And we'll go back and reduce them in just a second. 4 pi over 6, 5 pi over 6, and then 6 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Of course, we're going to keep going. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6, or 2 pi, because 12 divided by 6 is 2. So we're going to finish this. Let's see, 5, 6. This will be 7 pi over 6. This is 8 pi over 6. This is a pi over 6. This is 9 pi over 6, or 3 pi over 2. It's the same thing because it just reduces. 2. Hello. 2, 3 pi over 2. 8, 9, 10 pi over 6. And of course, we're going to reduce that. 10 pi over 6. 11 pi over 6. And 12 pi over 6 or 2. So this one can be reduced to 1/3. This would be 1/3, or pi over 3. Not this. We're going to reduce. That one's already reduced. This one can be reduced to 2/3. So 2 pi over 3 is this one. That one can't be reduced. This one's already reduced. We had 6 pi over 6. 7 pi over 6 can't be reduced. 8 pi over 6 would be 4/3. 4/3 over 6, so 4 pi over 3. We already reduced the next one. 10 pi over 6 could be reduced to 5 pi over 3. So this one would be 5 pi over 3. and then 11 pi over 6 can't be reduced, and we already deduced that. So that's where those measures come from. But now there's a whole lot more special right triangles going on here, right? A whole lot more. So we've got this one that's a 30, 60, 90 with the 30 reference angle. And then let me do this one in red. And then we've got this one. You see this one right here, this pink guy, is a 60 degree. This is our 60 degree, and then our 30's up here. So it flip-flops those ordered pairs. Okay, so let's look at our green one first. Look at the measurements from our special right triangle. Let me change back to green here. So we've got our green 30, 60, 90 triangle, and we always drop our perpendicular to the x, so this one's going to be 60 degrees. And so our measurement here is the one across from the 60. So this is the square root of 3 over 2, and this is 1/2. So our ordered pair right here is the square root of 3 over 2, positive 1/2. Remember, the side opposite the 30 is the 1/2. The side opposite the 60 is the square root of 3 over 2. So that's going to be, what is the ordered pair at pi over 6 is square root of 3 over 2, 1/2. Let's think about that for a second. If you were here, I'd ask you if you had questions, but you're not. So we'll move on to the pink one. So this one is our 60 degree reference angle, and we've got to come up with the ordered pair. So let me change my pencil to the pink color. Okay, so now we're going this direction across from the 30 degree angle. So from here to here is a 1/2, and from here to here is the square root of 3 over 2. So it's going to switch. So this one's going to be 1/2 square root of 3 over 2. Okay, and that's where that order pair comes from. And you can do that all the way around the unit circle just by using what you know about the special right triangle 30, 60, 90. Okay, so that's how that's going to work. And then you're going to take those two and you're going to merge them together to get your fabulous, wonderful unit circle. Ta-da-da, here it is. Okay, here it is. So, and I posted the unit circle as an attachment on the message board where you saw this recording, so you should be able to see that and print that and have it. So you've got a 30 degree angle, a 60 degree angle, reference angle, and that's where all of these ordered pairs come from. Now, it's a pattern. Math is just about patterns. So let me think about, how do I remember this pattern? I just know them, so I have to think about how I always go. Let's see, there's a way to do this. I don't remember how I explained it. I came up with a really cool, it's just counting. It's like 1, 2, 3, 3, 2, 1. Everything's over 2. Oh, that's it. It's 1, 2, 3, 1, 2, 3. The 2's are on square roots. So it's just counting. 1, 2, 3, 1, 2, 3. Okay, same thing over here. You got to remember the signs, right? Start at the bottom. 1, 2, 3, 1/2, and then the 2's and the 3's are on square roots. 1, 2, 3, 1, 2, 3. So you can just remember the pattern. It's always on the inside first. 1, 2, 3, and then on the outside 1, 2, 3. On the inside 1, 2, 3, and on the outside 1, 2, 3. And you have to remember the signs, and you have to remember the 2's and the 3's in the numerator have square roots on them. So it's not a ton, but it's a lot of information. Now, why are these ordered pairs so important, and why do we care? Well, probably going to the grocery store and living your life in a normal time, you don't really care. But in math, you're going to care. So the reason these ordered pairs are so important is because the first part of the ordered pair is the cosine of the angle, and the second part of the ordered pair is the sine of the angle. It's alphabetical. Cosine's first. So if I wanted cosine of 60 degrees, I know it's a 1/2. If I wanted sine of 5 pi over 4, I'm going to go to 5 pi over 4. And sine of 5 pi over 4 is the second part of the ordered pair, so it's negative square root of 2 over 2. I can look at my unit circle and give you the cosine and the sine, and eventually I'll show you how to do the tangent, but the cosine and the sine of every angle on the unit circle that is a special right angle, a 30, 60, or 90, or 40, a 30, 60, 45 degree angle, reference angle. I can tell you what the sine and cosine is just by looking at the unit circle. That's kind of cool. So let me, hold on a second, let's do this. So let's say I wanted to do cosine of 7 pi over 6. Oops, over 6. 7 pi over 6, not that. I don't know what I was doing there. All right, so I'm going to go to 7 pi over 6. I know that cosine is the first part of the ordered pair, so that's negative square root of 3 over 2. I'm done. I don't have to do, and don't give me decimals here, because I know you can punch that in your calculator. I don't care what the calculator says. I want to know that you can use the unit circle to get those exact values. And when it says exact, it wants a square root of 3 over 2, not 0.76, whatever it equals. Okay. Ooh, did I do that right? I think I did. Hold on. Square root of 3 divided by 2. Oh, 0.866. That's it. 73 is something else. That's square root of 2 over 2. I don't know. Okay. Getting off target. So that's why do we need these ordered pairs? Because we can give the cosine and the sine of all special right angles off of the unit circle just by looking at the ordered pairs. Cosine are the first order pairs, so cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. And the sine is the second part of the ordered pair. And that's why it's important to have the positive or negative correct, because like down here, sine of 5 pi over 3 is negative square root of 3 over 2. And you need to know that. So that's kind of how you're going to use the unit circle. That's a little bit more information, a little bit of how to deal with those ordered pairs and what to do and what does that mean. Practice, 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 practice. Have I mentioned you need to practice? You've got to practice this. It's not that complicated, but it's a lot of information. And if you don't take the time to practice it, you're not going to master it. You're not going to be able to have that be your knowledge. It's just something you looked at and read about, but you don't know it yourself. So in order for you to make that your knowledge, you've got to pick up your pencil, get a piece of paper, open up that online textbook, and do the practice problems. Check your work so you can make sure that you're doing those correctly. Let me know when you need help or if you have questions, because I am absolutely happy to help. You can also use Khan Academy as a good resource, and you can also use hotmath.com as a great resource. It's one of those that you can put, give you a practice problem, and you can put in your step-by-step, and it'll tell you if you're right, and if you're not sure what to do, you can ask for a hint, and it will tell you what the next step is. And so then once you get done, if you want a problem just like that, it'll give you another problem just like that. So you can practice until you feel proficient and until you can do it your own self without getting the hint. So those are kind of cool. All right, so hopefully that's helpful to you, and you'll have a good rest of your day or evening or whenever you're watching this. Talk to you later. See you in live lessons.